Now I introduce a dueling deep Q network. The definition of the advantage function A is defined as this A equal to this action state value function Q minus this state value function V. And this A is satisfied with the expectation of this A equal to 0. That means our agent at the current state S takes this action, and the agent moves from this state to this point as A. It cannot move to the next point without the environment information because it doesn't know where it should land. So from this point, we can step by step calculate the return from this point until to the terminal state and come back and get a return. If this Q value is a maximum, then this action A is the optimal action. And then we calculate the optimal state value function. However, right now, we have this Q, but the Q is at this point. It means it's just at this state S, but this after we selected this action A. What we want to agent stands here and describe this actions, not from here. Or we can find the relation between the state value function and the actions at this point. So to do so, that's why we defined this advantage function A. Then I use this advantage A function A, then we can modify the double deep Q network. We keep the target network same, but we only need to modify the Q network. We keep the same input, same output, and the same convolutional module. We only insert the two output module. One is for the state value function V, another one is for the advantage function A. And then we use this V and A, we combine to find the output Q over all the possible actions. That's the idea of the advantage function and what's the dueling Q network. Let's get a complete idea. Here, this is the double deep Q network, which includes two networks. One is a Q network, another is target network. Target network is just from the action here is from the Q network get this A, and then we just copy the parameter for the Q network to here, just run a forward path and get the Q at this action A. And then we use this Q plus this incident real world use the target to train the Q network. Right now, as we mentioned, we keep the same input and we keep the same output. We insert the two output modules. One is for the state value function V, another one is for the advantage function A. And then we use this V and A to calculate the Q distribution over the possible actions A. Here we use the replay buffer to improve the stability and the accuracy. So to use the gradient descent method to train the dueling Q network, we need to define a loss function. Loss function here we sample from the replay buffer. And here we define the target, like here we already showed. And we use this as the loss function. here, we show here, this is the target. And then we calculate, use the 7 gradient method to calculate the gradient of the loss function. And then we get the update for the model model parameters of the Dueling Q network until we get the convergent network parameters. Then we can find the optimal policy. By using the state value function V and the advantage function A to calculate the Q function Q, the action state value function Q, if we directly use this formulation, then now we will have an issue, because if we have a number, add a number here and a minus number here, and then we will get the same Q. So to avoid this issue, let's try a case. For example, we select this action A, makes this maximum, and then according to the definition, then this maximum Q equal to this V at the state S. So this term should be 0. However, this term is is just maximum. By selecting this A makes this maximum, we have this actual term. So we use this term as the baseline, insert to this equation, and we don't have that issue anymore. However, this maximum, that means every time when we calculate the Q from V and A, we need to scan the action space, find the maximum advantage A. That's where takes time, or changes from iteration to iteration. In practice, we use this average to replace this maximum term. We got this updated equation. This will get the better and a stable result. For more details, please check with this reference. Thank you. Bye.